In this video, we'll look at finding x-intercepts and y-intercepts of higher degree polynomial functions, meaning third degree or higher. To find the y-intercept, let x equal 0 and solve for y. To find the x-intercept or intercepts, because there could be more than one, let y equal 0 and solve for x. You may need to use factoring strategies that you learned previously in the course. Let's look at some examples. Example 1 says, find all y-intercepts and x-intercepts of the graph of the function. The first one is f of x equals 2x cubed minus 2x squared minus 84x. So the first thing I want is the x-intercept. So to find the x-intercepts, what I'll do is I will let y equal 0. That's the same as letting f of x equal 0. So 0 equals 2x cubed minus 2x squared minus 84x. So remember, to solve this, I may need to use factoring. So what I look for first is a greatest common factor. In this case, they all have even number coefficients, and every term has an x involved. So I could actually factor out a 2x. So I have 0 equals 2x, and then what's left from the first term is x squared. The second term, I have minus x, because if I multiplied minus x by 2x, I would get the negative 2x squared. And then 84 divided by 2 is 42. And I've already accounted for the x, so I'm just going to have a 42 there. Okay, so I get 0 equals 2x, and now I want to factor the quadratic more. Because there's no number in front of the x squared, it's a 1x squared, so x times x. Now I want two numbers that multiply to be negative 42 and add to be negative 1. So what if I tried a plus 6 and a minus 7? 6 times negative 7 gives me negative 42, and 6 plus negative 7 gives me a negative 1x. Perfect. Now I use the zero factor property. So I will have the first factor is 2x, so 2x equals 0. The second factor is x plus 6. So I have x plus 6 equals 0. And the third factor is x minus 7. So I have x minus 7 equals 0. All right, so the 2x equals 0. If I divide both sides by 2, I get x equals 0. X plus 6 equals 0. If I subtract 6 from both sides, I get x equals negative 6. And for x minus 7 equals 0, if I add 7 to both sides, I get x equals a positive 7. So those are my x-intercepts. If you want to list them as ordered pairs, the x value always gets listed first. So the first one would be 0, 0. The second one would be negative 6, 0. And the third one would be 7, 0, because the y value for all of those x-intercepts was 0. So these were the x-intercepts. All right, now the y-intercept is usually a little bit easier. For the y-intercept, you let x equal 0. Let x equal 0. So we're going to have y equals 2 times 0 cubed minus 2 times 0 squared minus 84 times 0. And since anything times 0 is 0, we're just going to get 0 out of that. So the y-intercept is going to be 0, 0. And if they just want the y value, you would just enter 0 for the y-intercept. All right, let's look at the next example. We have f of x equals x cubed minus 3x squared minus x plus 3. Now, thinking of the factoring strategies from earlier in the semester, if I have 0 equals this function and I want to solve, I want to try to factor, and there's 4 terms, so I'm going to try factoring by grouping. So x-intercepts, we let y equal 0. So I end up with 0 equals x cubed minus 3x squared. And I'm going to write this as a plus negative x plus 3. I'm doing that so that I can group it appropriately. So if I want to do factoring by grouping, what I would do is I would group the first 2 terms together. I would group the second 2 terms together, but I have to have that plus between the 2 groups. So I have a plus between groups. So I haven't factored it yet. All I've done is I've grouped the first 2 terms and the second 2 terms together. All right, so now I want to pull out the greatest common factor from each group. So here, the x cubed minus 3x squared, the greatest common factor is x squared. So if I pull that out, I get x squared times x minus 3. Here, I want to pull out the negative that's in front of the x. So I'm going to pull out a negative 1. And that changes the sign of each term in the parentheses. So I'll get negative 1 times parentheses x minus 3. And at this point, if you recall from factoring by grouping, it's really important that you get the same thing in your 2 sets of parentheses. And that now is the greatest common factor between the 2 terms. And so if I pull out that greatest common factor, I'll get x minus 3, that's my GCF, and I look at what's left from the remaining terms. So x squared from the first term and minus 1 from the second term. Now, I'm not quite done. This is the difference of squares. So it can actually factor as x plus 1, x minus 1. So I'll get 0 equals x minus 3 times x plus 1 times x minus 1. And because the whole thing equals 0, I can use the 0 factor property. So the first factor, x minus 3, would equal 0. The second factor, x plus 1, would equal 0. And the third factor, x minus 1, would equal 0. And you just want to solve each of those. So the first one, you'll add 3 to both sides and get x equals 3. The second one, you would subtract 1 from both sides and get x equals -1. And for the third factor, you would add 1 to both sides and get x equals +1. So my x-intercepts are at 3, -1, and +1. Those are the places where my graph crosses the x-axis. And then for the y-intercept, remember what we do is we let x equal 0. So if I'm letting x equal 0, I'm going to get y equals 0 cubed, which is just 0, minus 3 times 0 squared. That would also just be 0, minus 0, still at 0, plus 3. So that's just going to equal 3. And so my y-intercept is going to be at the point 0, 3.